Alkanes are named by combining a prefix for the number of carbon atoms in the chain with the ending ane, A-N-E. So in this table, you can see the numerical prefixes with the ending ane for simple alkanes from 1 carbon all the way up to 12. So from 1 to 4 carbons, meth, eth, prop, and bute, methane, ethane, propane, and butane, these prefixes are special, specific to chemistry. And so you're going to have to know these off by heart. They're something that you should be memorizing. The rest of these, from 5 all the way up to however many carbons you can count, are the more traditional numerical prefixes. They come from Greek. So like how an octopus has 8 legs, octane has 8 carbons. So this molecule here on the top has 1, 2, 3, 4 carbons. So we name this molecule butane. Bute for 4 and ane because it's an alkane. Cycloalkanes are named by putting the word cyclo in front of the alkane name. So this ring has 1, 2, 3, 4, 5 carbons. So we would call this cyclopentane. And again, I've put some of the most common rings you'll see in the table and highlighted the numerical prefix for the number of carbons in the ring. And these are ones, again, that you're going to want to get really familiar with. So right away, when you see cyclopropane, you know that it's a 3-carbon ring, or cyclobutane, you know that it's a 4-carbon ring. Now, the vast majority of the molecules that you're going to see in your organic chemistry course are not going to be simple straight chains or plain unsubstituted rings. This molecule here, for example, is an alkane with some branching. We call this branch a substituent because it has been substituted in the place of where a hydrogen atom would be on the plain alkane. In order to name substituted alkanes, we're going to be following 4 simple steps. First, we're going to find what's called the parent structure. The parent structure is the longest continuous chain or ring of carbon atoms in the molecule. It's called the parent because everything else in the molecule belongs to it. So let's find the parent structure for this molecule here. We can count 1, 2, 3, 4, 5, 6, 7 carbon atoms. And so the parent structure is going to be called heptane. Hept for 7 and ane because it's an alkane. Next, we're going to name the substituent. And so I've circled the substituent in orange here. It's a 1-carbon substituent. So to name a substituent, we're going to take the root for the number of carbons, and we're going to add the ending -il, so YL. So this 1-carbon substituent would be meth for 1 carbon and -il because it's a substituent. It's a methyl substituent. Now, the next step is that we have to assign a locant to the substituent. A locant is like an address so that you know exactly where to find the substituent along the parent structure chain. And so first, before we can assign it an address or a locant, we need to number the whole parent structure. So if we look at our 7-carbon chain, we have 2 choices. We can start numbering from this side, and we would get 1, 2, 3, 4, 5, 6, 7. Or we could start numbering from this side, and we would get 1, 2, 3, 4, 5, 6, 7. Now, the rule with assigning a locant is that you want to give the substituent the lowest possible number that it can have. So we would choose this numbering in black the first way that I numbered the molecule because that would give the methyl substituent a locant of 3. If we went the other way, the methyl substituent would have a locant of 5. So 3 is better because it's lower. So this substituent is going to be called 3-methyl. Now we put the name together. We start with the parent structure, heptane, and directly in front of the parent structure name, we're going to add the substituent, 3-methyl. So our molecule is called 3-methylheptane. Now, there's no space in between methyl and heptane. It's one word. Spaces are used for very specific reasons only in IUPAC naming. And so between the substituent and the parent structure, there's no space. And we always put a dash between the locant and the substituent name. So 3-methylheptane, one word. Let's do a little bit of practice naming some other molecules like this. Okay, so the first thing with this first molecule that we're going to do is we're going to find the parent structure. So we can count 1, 2, 3, 4, 5, 6 carbons. If we go that way, we could also count 1, 2, 3, 4, 5, 6, 7 carbons if we go that way. So that's the longer chain. So I'm just going to erase these. And let's mark our longest chain in pink here. 1, 2, 3, 4, 5, 6, 7 carbons. Okay, so 7 carbons, just like our last example, the parent is a heptane. Now, let's find the substituent. So anything that's not on the main chain is a substituent. So we'll highlight that in orange. The substituent has 1, 2 carbons. So for 2 carbons, we use F and then YL. So it's an ethyl substituent. So we've got our substituent, we've got our parent chain, and now we just need the address for the ethyl group. So let's number. If we number this way, we get 1, 2, 3, 4 for the ethyl group. And if we number the other way, we can see we get 1, 2, 3, 4 as well. So either way that we number, we're going to get 4. So 4 is our locant. So we'll just put that in front of the ethyl. And then we'll put everything together. 4 ethyl heptane. That's our name. Okay, so for this next example, we have a ring, a cycloalkane with a substituent on it. So first, let's find out how many carbons are in that ring, because it looks bigger than the chain. 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons is an octane, but this is a ring. So the parent is cyclooctane. And the substituent is anything not on the parent there. So it's another 2 carbon substituent. So this is an ethyl group. Ethyl. And the locant, the address of the ethyl group. So what do we do? How do we number a ring? Because a ring is a big circle, right? When you just have one substituent on a ring, you can choose that locant to be 1. So this will be a 1 ethyl substituent. So this will be 1 ethyl cyclooctane. Beautiful. Okay, here's a third example. Here we have a ring and quite a long chain. So we actually need to compare these and decide which is going to be the parent structure, the ring or the long alkyl chain here. So the ring is a 1, 2, 3, 4, 5, 6. So the ring is a cyclohexane. And the alkyl chain here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's more carbons in that long straight chain than there are in the ring. So we're actually going to choose that straight chain to be our parent structure. So I'm going to go and be consistent, and we're going to highlight our parent structure with pink. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons is a nonane parent. And then this whole ring, is our substituent. So we'll call it cyclohexane. cyclohexyl substituent. And now we need an address or a locant for the cyclohexyl substituent. And for this 9-carbon chain, the cyclohexyl is located on this carbon here, which is pretty obviously, hopefully it's obvious to you that we're going to call this 1. We could number the other way and call that carbon 9, but it's much better and much more in keeping with the rules of IUPAC nomenclature to choose 1 for that position. So we'll have a 1-cyclohexyl, and this will be 1-cyclohexyl nonane. For our last example, we are being asked to draw the molecule from a name instead of the other way around. So this should be fun. It's asking us to draw 1-propyl cyclohexane. So if we look and break down this name, the part that is the parent structure is that last part. So cyclohexane is going to be our parent structure. So let's draw that. So that's a ring with 6 carbons. We just draw that as a nice little hexagon. And then our substituent is 1-propyl. So because this is a ring and there's nothing else on it, I can actually choose any of these carbons in the ring to be position 1. So let's just choose this one here. We'll call it 1. And we're going to put on a propyl substituent. So prop is the prefix for 3 carbons. So 1, 2, 3. So I'll just highlight those so you can see 1, 2, 3 carbons on our 6-carbon parent. So that's 1-propyl cyclohexane. So when we have more than one of the same substituent on a molecule, we're going to add what's called a multiplier to the substituent's name. So we'll add a di if there are 2 of one substituent. So for example, this molecule has a parent structure of 5 carbons there. So that's going to be a pentane. And then there are 2 methyl substituents, one here and one here off of that main parent chain. So to signify that we have 2 methyl groups and not just one, the substituent name is going to be dimethyl. If you had 3 methyl groups, it would be trimethyl. If you have 4 methyl groups on a molecule, it would be tetramethyl, and so on. And now to put the name of this molecule together, we have to have the addresses for both of those methyl groups. Remember, the locants. And so we want to choose the numbering that gives the lowest set of locants, not just the lowest one number, but now we're considering multiple numbers. So I'm going to show you this. I'll number starting at this end in black. 1, 2, 3, 4, and 5. And then I'm going to number starting at this end here in pink. So 1, 2, 3, 4, and 5. So for our locants, let's do a little comparison here. So numbering from the left to the right, we have our methyl groups at 3 and 4. But if we look at the pink numbering from the right to the left, then we get a 2 and a 3. So to decide numbering like this, you're going to look at your locants and you're going to look at the first spot where there's a difference in the numbering and choose the lower number. So here, if we look at the first numbers, we're comparing 2 and 3. 2 is better, it's a lower number. So we're going to choose that set that gives us 2, 3 rather than 3, 4. That's a better set of locants. So I'll just circle those. And then we're going to put both locants in front of the word dimethyl, and we're going to separate them with a comma. So 2, 3 dash dimethyl. And we'll put all of those parts together to get the molecule name. 2, 3 dash dimethyl pentane. Now I'll explain what you do when you have a molecule with multiple but different substituents. So let's just go through this example to show you how to do that. Let's find the parent structure first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. So this is going to be a decane. I'll just write that down. Decane is our parent. And let's find the substituents that are on our decane. So here we have a 1 carbon substituent. And here we have a 2 carbon substituent. So first we'll just name those. So 1 carbon is methyl. And 2 carbons is ethyl. So we have a methyl and an ethyl substituent on our decane parent chain. So when you have found your multiple substituents, you are going to arrange them in alphabetical order in front of the parent structure. So I'm just going to highlight here, we've got M versus E, and E comes alphabetically before M does. So when we put this molecule together, it will be an ethyl methyl decane. And I'm just going to write it like that, even though we haven't added the locants in yet. That'll just remind me exactly what order we're going to connect those parts of the word in. So E before M. All right, and then finally, we are going to look for locants again. So I'll number here from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then if I number from right to left, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can see with the black numbering, the lowest set we would get is 5 and 8. And with the pink numbering, the lowest set we'd get is 3 and 6. So that's a better numbering, 3 and 6. So I'm going to just circle those locants, 3 and 6. And so we're going to put those numbers into our name. The locant goes right before the substituent that it refers to. So for ethyl, its locant is 6. So we're going to call this 6 dash ethyl. And then the methyl, we found that its locant was 3. So we'll go dash again, and then 3, and then dash again, methyl decane. Okay, so if you notice in this molecule, the numbers aren't in order. It's the substituents, the first alphabetical letter that are in order, and you'll see the numbers out of order. So this is an area that you can get tripped up on, because sometimes you might think, oh, I need to put the numbers in order, but you actually don't. You need to put the substituents in alphabetical order and then add the numbers in. That's why I like to write out ethyl methyl decane first, and then write out the full name again once I've figured out the locants. So 6 ethyl, 3 methyl decane. Okay, we're going to do a little bit of practice with naming molecules with multiple substituents, or alkanes and cycloalkanes with multiple substituents on them. So here's our first practice example. We have a cyclic molecule, a cycloalkane, and it's got, I mean, you should be getting used to this by now, that when you see a hexagon, it's a cyclohexane, but I will highlight all the 6 carbons just so you can see. So this is a cyclohexane parent. All right, and then what do we have for substituents? We have a methyl group here and a methyl group here. 2 separate one carbon substituents. So we're going to call that dimethyl, right? Because there are two methyl groups. Dimethyl. All right, and so how do we assign locants on a ring and when these two substituents are both on the same carbon atom? So remember, for rings, when there's nothing else on the ring, we can choose number 1 for where the substituents are. So these both methyl groups are on the same carbon, so we're just going to call that carbon number 1. There's nothing else to deal with here. And both of the methyl groups are on carbon 1, so we have to actually state the locant 1 twice, just to be super clear that there are two methyl groups and they're both in the same spot. So that's going to look like 1, 1 dimethyl. So altogether, this is 1, 1 dash dimethyl cyclohexane. Okay, next example, we have this great big kind of branchy molecule, and let's check out, I can't just right away tell what is the longest chain, so we're going to look at some options here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could also number from the bottom, so let's just check out this option. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's another 10 carbon chain, but it's actually the same. So in both cases, numbering the 10 carbons will give us a methyl substituent and a 3 carbon substituent. So if we choose the green dots for numbering, or the green dots for our parent chain, we would get a methyl here and a propyl, 3 carbons. And if we choose the pink numbering, we would get a methyl and a propyl, 3 carbons. And those are identical compounds. So it totally doesn't matter which way you draw your numbering in this case. So I'm just going to erase my green numbers, or my green dots. Just going to erase my green dots. And so how many was this? Now I'm lost and I don't remember how many carbons it has. 10, right, okay. So a decane parent. And then we said we have a 1 carbon substituent there. So that's methyl. And then we have a 3 carbon substituent here. 1, 2, 3. So that is a propyl. Okay, so let's arrange our substituents in alphabetical order first, just so we know definitively how they're gonna look in front of the parent name. So we have M versus P. So M is earlier alphabetically than P. So this will be a methyl propyldecane. Methyl propyldecane. And then we will do our numbering. All right, so let's go from left to right. I'm just going to write the numbers where the substituents are. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we can do it the other way from right to left in pink here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is an interesting situation here. We have locants of 4 and 7 versus 4 and 7. It's the same, it's a tie. Either way we number from one end of the molecule to the other, we're going to get 4 and 7. So we'll either have 4 methyl 7 propyl or 4 propyl 7 methyl, one or the other. So how do you choose in this case? So in this case, when you do have a tie, you can give the lower locant to the first alphabetical substituent. So this is the situation where you are also going to put your numbers in order the same as your letters. But that's only when you have a tie like this. So we're going to choose the numbering that gives methyl the lower number because methyl is first alphabetically. So we're going to be choosing the pink numbers here. So that gives us 4 methyl, 7 propyl decane. Okay, 2 more practice examples just so we really absorb this information. Here's our lovely molecule. I can see 1, 2, 3, 4, 5, 6 carbons is the longest I can get here. So that's a hexane for the parent. And then I see a 1 carbon substituent here. And I see a cyclic 3 carbon substituent here. So this is, we know, a methyl. And so when you have a cyclic substituent, it's the same as how you would name a linear substituent, but you just put cyclo in front of it. So 3 carbons would be a cyclopropyl substituent. And we're going to arrange these alphabetically in front of the parent structure. So we have C versus M. C comes before M. So we're going to have cyclopropyl methyl hexane. Sorry, I had to squish my writing in there. So cyclopropyl methyl hexane. And then the locants. All right. So I'm going to do this one sort of just by observation. I can already see that if I number from the right going sort of to the left and down, I'm going to get a 2 for the methyl. And if I start the other way, the best locant I'm going to get is a 3. So I can just automatically go this way because I can visually see that this is going to give me lower numbers. So 1, 2, 3, 4, 5, and 6. So our numbers are 2 and 4. So we're going to add those in. 4 cyclopropyl, 2 methyl hexane. Okay, the last example, we're going to go from a name to a structure again. So this is asking us to draw 2, 3, 5, 5 tetramethyl decane. So let's find our parent structure first. That's just this last part of the name, decane. And decane is 10 carbons. So we're going to draw 10 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to add our substituents. So we have tetramethyl. So that means there are 4 methyl groups. And they are located at 2, 3, 5, and 5. So let's just, when we're drawing the molecule, we can just pick an end before we put the substituents on. So I'm going to just call this carbon number 1, and we'll go from here. So 1, 2, so there's 1 on carbon 2, methyl group. There's also 1 on carbon 3, nothing on 4. And then on 5, there are 2 methyl groups. So here and here. 1, 2, 3, 4. 4 methyl groups on a decane parent structure. 2, 3, 5, 5 tetramethyl decane. So we're going to look at this big molecule on the bottom of the page, and it's got a nice big old substituent here, and that substituent also has a substituent on it. So let's start by finding the parent structure. That's going to be the first step. So this molecule has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. So that big long parent is a dodecane. Just highlight that so we know that's the parent. And so here are the steps that we're going to take to name the substituent that's coming off of that dodecane. So I'm just going to circle the whole substituent in orange so you can see it. So first we're going to find and name the substituent's parent structure. So just as we've done before, the longest chain of carbons in the substituent, and then we'll use the YL ending. So the longest chain that I can find is 1, 2, 3, 4 carbons long. So the name of the substituent is butyl for 4 carbons. Then we're going to identify and name the substituent that's on the substituent. So I'm going to circle this in blue. There's a methyl substituent on that butyl substituent. Okay, and then we're going to find a locant for the methyl group, a locant that refers to where it is on the butyl substituent. And so to do that, we're always going to number the main substituent starting at the point of attachment to the main chain. So this is carbon 1, where it attaches here to the main dodecane chain, and then 2, 3, and 4. So the methyl substituent that's on the butyl substituent is on position 2. So we'll put a 2 in front of it, 2-methyl. And now to name this whole entire substituent, we're going to enclose it in parentheses. So like this, 2-methyl butyl. So that whole piece, 2-methyl butyl, is the name of the substituent that is on the dodecane chain. Dodecane. Now we need to give a locant for that whole entire substituent so that we can specify where it is on the dodecane. So if we go this way, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So 6 is going to be the lower locant. We're going to number this way. And so we would put that locant in front of the whole entire substituent name that's in parentheses. So 6-2-methylbutyl in parentheses, dodecane. So naming branch substituents like that, I think is really fun, but chemists also like to be lazy and save time. So some of the very common branched alkyl substituents have common names that IUPAC allows. So here are 4 of them. You're probably going to see them all the time in your organic chemistry course. So these are structures that you will probably need to memorize. So this one is isopropyls. So the pink is part of the parent structure where the isopropyl group attaches. So I'm just going to draw a squiggly line there to show you that that's the bond where it attaches. And this is the substituent, isopropyl. It's 3 carbons and it's attached at the middle or the second carbon. And the I is used for alphabetizing when there's more than one substituent there. This is the isobutyl, so this is the bond where it attaches, and then these are the 4 carbons in the isobutyl group. Again, there's an I for alphabetizing. These 2 are a little trickier. This is secondary butyl. That's where it attaches to the parent structure, and then these are the 4 carbons. And with sec-butyl or secondary butyl, we actually use the B. I do not know why, but this is how it goes. So the B is used for alphabetizing, and then this is tertiary butyl or tert butyl, and it's the same thing. The B is used for alphabetizing that substituent. So make sure that if your professor uses these names for these branch substituents that you memorize them because they're useful, especially the tertiary butyl group. I feel like that one comes up a lot when you learn reactions later. All right, it's time for some practice naming complex or branched substituents. And this is going to wrap up our alkane section. These questions are going to cover everything that we've learned up to now. So here's a nice molecule. There's a cyclohexane ring, and let's see how many carbons are in this alkyl here. 1, 2, 3, 4, 5. So that means the cyclohexane is the parent because there are 6 carbons in the ring and only 5 on the main part of that alkyl substituent. So I'm going to write cyclohexane for the parent. And we counted 5 in the longest chain on the substituents. So we know it's a pentyl substituent. And then our substituent has a substituent. So that's this methyl group here. So it's a methylpentyl group. And then we have to specify where that methyl group is on the pentyl chain. So where it attaches is carbon 1, 2, and then this is carbon 3. So we have 3-methylpentyl. I'm going to put that in parentheses. So that's the name of the entire substituent that's on the cyclohexane ring. And then we need to specify where that entire substituent lives on cyclohexane. And since it's the only thing on a ring, we can call it 1. So this would be called 1 dash parentheses 3-methylpentyl cyclohexane. Big long name. All right, the next example, let's look for the longest chain. So we'll start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's look starting down at the bottom to make sure that we get the right chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we could follow the pink dots to get a decane, or we could follow the green dots to get a decane. So which one do we choose? We have a choice. So if we follow the pink dots, we're going to have 2 substituents. I'll circle them. So we'd have this branched substituent here and this branched substituent here. Now I'm going to erase those. And if we follow the green dots, we have 3 substituents. We'd have a methyl, we'd have this 3-carbon substituent here, and then we'd have that branched one again. So which one are we going to choose? So here's a guideline from IUPAC that I haven't mentioned yet because it's just easier to teach within an example. If you have a choice with your longest chain, you're going to pick the chain for the parent that gives more but simpler substituents. So that means we would pick the green dots because we'd end up with 3 substituents, but 2 of them would be simple instead of picking the pink where we would get only 2 substituents, but we'd have a branched substituent. So basically we're picking the chain that avoids the branched substituents where we can. I hope that makes sense. So I'm just going to erase everything on the molecule and start again just so we can be really clear about what we're talking about. So let's highlight the parent structure in pink again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our parent. Now I will circle all our substituents. There's 1, 2, and 3. So this is a methyl group. Oh, I forgot to write down our parent structure name. It's decane for 10 carbons. Okay, and this is a methyl. This is a propyl, so 3 carbons. And this is one of our special branch substituents. This is the tertiary butyl. Butyl. Okay, so propyl, and remember tert butyl alphabetically starts with a B. I've highlighted all of those. So now we're going to arrange our substituents in alphabetical order. So B comes first, tert butyl, and then M for methyl, and then P for propyl. And then we are going to assign locants. So I'm just going to do it the quick way. If I go for this side, I see that the first thing I'm going to hit is a 3. And if I go this way, the first thing I'm going to hit is a 4. So 3 is better than 4. So I am going to go from the bottom here. That is going to make 1, 2, methyl 3, propyl 4, 5, 6, 7, and tert butyl 7. So I'm going to now add those locants in and put the whole name together. So we've got 7 tert butyl, 3 methyl. Sorry about that. We ran out of memory for recording, but we're back. So that is 7 tert butyl, 3 methyl, 4 propyl, decane.